Assalamualaikum warahmatullahi wabarakatuh. Hello Mr. Dai and hello guys. My name Rizky Subekti and my NPM 1906301772 and I'm from Naval Architect and Marine Engineering. Today I will presentation about my final project. The title of my final project is Numerical Analysis Dynamometer or water break using Computational Fluid Dynamic Software. And enjoy with my presentation. Now, this is a table of contents. Number 1, abstract. 2, introduction. 3, theoretical analysis. 4, variable simulation in Fluent. 5, conclusion. And the last is reference. Abstract. One of the most popular internal combustion engine is the engine in the transportation device. Power is a parameter that shows the capabilities of an object that give energy. For example, the internal combustion engine. Power in this engine is measured by a device called dynamometer. The CFD or Computational Fluid Dynamic Software was simulated several impeller variables to absorb power of engine. With that result, we know the biggest dynamometer absorber power, cheapest and easy to be made. The hydraulic dynamometer is selected type of dynamometer as the result of design process. The basic principle of a hydraulic dynamometer is the same as centrifugal pump, but it has low pump efficiency. The result of the test are maximum power and torque of the test engine and the operation area of the select hydraulic dynamometer. The next is introduction. Combustion engine is one of heat engine type which applied in many sectors, such as transportation, industry, power station, and etc. Combustion engine power is important to be known to measure working performance of engine. Work performance of fuel combustion engine is known using power measure device. Power measure device, which the most applied and has popular in many market, is dynamometer. Work principle of dynamometer is by giving resistance and rotation of crankshaft. Torsion effect, measure, and power combustion engine will know through calculation. In this exercise, the writer tries to simulate performance of absorption dynamometer water break type with numerical method. It is used to measure fuel combustion engine with computer software which has been developed and popular. Numerical method has more advantage compared with experiment method. It obtains various data, cost relative cheap, time setup relative short, and it has not influence with environment factor. In this exercise, Fluent software used as basic simulating program. It is included in Computational Fluid Dynamic category or CFD software. Numerical method in this software can solve involved geometry and boundary condition, which is resist in experiment method. Fluent is one of the software CFD. Its principle work based on the finite volume method. The next is theoretical analysis. Theoretical analysis. The dynamometer used to measure perform combustion engine. Work principle of dynamometer is torsion as a result from rotation engine. The name is hydraulic dynamometer. Hydraulic dynamometer is one of absorption dynamometer. It uses fluid to absorb power engine hydraulic system, or the name is hydraulic system. Water usually applied as fluid where it is function as coolant and lubricant media. Hydraulic dynamometer has two important components that are moving vane rotor and steady vane is stator. And the rotor is rotated from engine, torque, and axis. Spin of rotor will give effect suction in the dynamometer. Water comes from outside to the dynamometer through the two inlet. Water and rotor rotate together. While rotating, water gives friction effect with rotation of engine and heat appears. The water flow continually through casing are important to decrease heat and as lubricate between seal and axis. Stator and casing are joining permanently. The arm is attached with casing, where at the end from arm edit measuring instrument. Using calculation result from measure instrument can be found torsional. Water from dynamometer is not enable exceed 80 degree Celsius. Water supply pump must clean, cool, and obtained constant. Advantage of hydraulic dynamometer are does not require permanent installation, easy to remove out from one machine to other machine, or the name is portable. Only need one operator, and the last have large range of power and speed. When idle, position of measuring instrument must show zero number. Dynamometer in balance. Measuring rotation of axis engine need to get performance of combustion engine is done to avoid dynamometer broke. And this picture of dynamometer. And the part is water circulation. To engine crank, water in and water out, stator, rotor, and stator housing rack to torch product, and torch meter, and tachometer measure or RPM. And next is calculation of sourcing impeller power. Power calculation are axis power and loss friction power in this. Number one is axial power. Rotation moment will get power same as like power give to axial. P and M omega. Where omega is angular velocity. Axial power can be expressed by like this. A loss friction power this. Fluid or liquid at rotate surface this, and casing move out from this. It happen because rotation friction force and radical centrifugal force appear, and expressed by like this. And the next is fluid force. Fluid force equation is given by, and like expressed by like this. And the next, the impeller efficiency can be expressed by like this. The next is variable simulation in Fluent at CFD software. Description problem at This simulation will be presented stream pattern at dynamometer with various impeller distance to wall. Like impeller, the wall SR, height impeller TR, number of impeller ZN, number of rotation impeller N, and inlet flow debit Q. Specification of dimension from impeller is shown in the picture. Dynamometer impeller B type blade encasing like this. This is the dimension. Speed of impeller rotary equal with speed of matching rotary, and flow rate. Water fluid enters through inlet and exit through outlet. During inside at dynamometer, impeller with water rotating together and decrease speed rotation of engine, water brake. This phenomenon will generate torsion. It is measured at center rotation with direction of axis Z. And the operation condition at this simulation, fluid material applied as reference are fluid type, water, or H2O liquid. The temperature is 27 Celsius. Fluid density 9982. Fluid absolute velocity like this, and the bit inlet fluid like this, and the last is velocity rotary impeller 3600 RPM. At the simulation boundary condition specified as follow. This is a boundary condition, and the picture explain the wall impeller, wall ini symmetry, pressure outlet, velocity inlet, and the next grid simulation in Gambit. Grid simulation basically it's done to get a good grid structure. It can predict complex stream pattern with a little number of cells. This setting structure obtained by doing various adaptation, pressure interpolation, same is default option in Fluent. It is used to adapt entire of simulation process. Flow fluid in dynamometer simulation is turbulent flow. And the calculation of pump theory. Dynamometer type water brake can be analogy as water pump with small efficiency pump using equation of the pump theory with same boundary condition and variable input will result power absorption impeller. This power absorption impeller can compare as validation calculation numeric. Calculation of absorption impeller is given by power axis. For a calculation, power give axis must pay attention to speed triangle. The speed triangle enter B1 90 degree. If it is compared to exit blade angle 20 degree interval 20 degree 80 degree, exit blade angle C2 90 degree has absolute speed out and the biggest increase height or height, and this a picture speed triangle entering like this and speed triangle exit like this. And is it a calculation about power axis, and we can see at the picture in the slide of my presentation like this. Power axis P value is value and omega value plus friction power value where velocity circumference is the value and absorption impeller power height value. Okay. And the assumption and key specific velocity 1 per minute and diafluida with by like this, and value is it impeller efficiency, and the efficiency is 0.038%. And the result of simulation setting nearest approach calculation to the pump theory is selected to analyze various dynamometer variable. The epsilon model using discretization second order for pressure, quick for momentum, and two-layer zonal model for near wall treatment give result torsion calculation with the pump theory. It is 8577 horsepower, reached with 2990 times interpolation, and the table is solution model like this, and the grid simulation is done to obtain a good grid structure. It is used to predict stream pattern with a little number of cells. And is it the result of impeller simulation type B? A dynamometer modeling simulation is need high performance of computer. It is influence require much longer time analysis. The symmetric method can solve but of problems without decreasing accuracy. This rotary stream pattern happen in space between rotor and stator. It cause of angular force as a result of rotary impeller. See figure 7. The effect of rotary impeller can show at particle motion at x-axis that are fluid particles at the end of impeller move perpendicular with blade area and opposite with direction of motion impeller. And this is a picture of total pressure. A is total pressure distribution at impeller, and B is particle fluid particle motion at cut field 25 millimeter from z-axis like this. And this fluent software in CFD Autodesk. And the next is addition number of blade impeller to absorption power impeller so increase stability, and now the blade amounts 18 and 20 power absorption difference reach smalls 105 and 111 horsepower. This thing indicates that for amount of blade more than 20 of power absorption reach stable. This is a graphic influence number of blade to power absorb of dynamometer impeller type B have not reached stable point yet, as shown in figure 11. This figure 11, input variable data number of impeller is limit until 20 because that condition is first difficult in casting process and also machinery process. At figures 11b show increase height of blade impeller cause the absorption increasing. However, there is maximum limit height impeller at 20 millimeter. This is cause of not friction between water fluid particles without surface of blade. It is happen only at the end of blade. It is zone pattern distribution pressure or at figure 7. Like addition impeller, it's also limited by strength material of impeller. Like this, the figure of 11A and B. In figure 12A, by improvement of distance impeller to casing wall will influence incident of friction force by fluid. Every greater path impeller to casing wall will give effect at the next at particular picture 12b show graph effect flow rate of water fluid to power absorb dynamometer absorption during informant flow rate of water fluid absorption reach increase also, but it changed sufficiently small to that graph's approach to horizontal. It concludes that the increase of water flow rate does not have effect with the increase of power absorption impeller. And the last graphic in figure 15, graphic effect speed of rotation impeller to the power absorb impeller dynamometer. Indonesian, grafik pengaruh variabel kecepatan impeller terhadap daya dynamometer. From selected variable simulation, the biggest dynamometer power, but can be made with consideration of relative cost of chip, strength of material, and relative easy machinery process. And the conclusion about my final project is simulation of stream fluid at dynamometer type B using option turbulence standard model, second order, quick, simple option approach that is appropriate for case sphere. Simulation of stream fluid at dynamometer type B with the same set option give variable data as follows. At simulation variable number of blade, the biggest power absorbed reach like this, and the blade amount of 18. At simulation variable weight in of impeller, the biggest power absorbed reach like this. At height impeller 40 mm. At simulation variable distance impeller to casing wall, the biggest power absorbed reach like this, and distance 4 mm. At simulation variable flow rate of water fluid, the biggest power absorbed reach like this at 4 GPM. At simulation variable speed of rotary impeller, the biggest power absorbed reach 185 horsepower at rotation speed 3600 RPM, rotation per meter. And from data of simulation selected variable that have the biggest dynamometer power absorbed, and it can be with consideration of cost, state of material, and machinery process. They are number of impeller is 15 mm. Impeller is 30 mm. Distance impeller to wall of casing is 5 mm. Power of dynamo capable to be absorbed 185 horsepower. If compared with real experiment method, the difference between result in TAS method big enough. This shown perform set option turbulence standard model in Fluent. It need further result using another turbulent models, RMS, Reynolds stress model, and LES, large AD simulation, to get the best set option in Fluent. And the last in my presentation, the reference like this, my pick the literature like this, name, book, and people. Last, thanks for your attention, and thanks Mr. Dai, thanks my friends. And it's a quote, jangan takut kalau hidupmu akan berakhir, takutlah kalau hidupmu tak pernah dimulai. From Grace Hansen. Thanks. Wassalamualaikum warahmatullahi wabarakatuh.